So we'll start with so our class today is centered on graphs. And the first one is sine and cosec graphs. That's the first one. So what is important here is to know that the original form. Hello.
So we'll prove the identities after this, or
Yeah, don't worry about the identities. We'll do them after the graphs in the next class. So f of x is equal to a sine bx plus c plus d. When you have such a structure, so every function of sine that you're going to see, take note that we have labeled its properties in this form, where we are naming the amplitude to be the modulus of A, the period to be 2 pi over B. When I say 2 pi, I mean 360 over B. Then the scale of the drawing is going to be the period divided by 4. That's the scale of the drawing. And then the first shift, will be given by equating bx plus c to 0 and solving for x. So you'll be getting negative c over b. Then the vertical shift, is obtained by getting the number standing alone. If it is positive, get it as positive. If it's negative, get it as negative. And we call it the vertical shift. So we have the first shift, the vertical shift, we have the scale, we've got the period, and we've got the amplitude. Like that.
so can you just please repeat on the period and on the what scale?
So the period, you just divide the 360 by b. So let me give you an illustration. Suppose you have a function y is equal to 2 sine, let me say negative 2 sine 3x plus pi minus 4. Then they ask you to find the amplitude. So you would say the amplitude is the modulus of the coefficient of sine, which is negative 2 in this case. So it will come out to be 2. That's the use of the modulus. The period is going to be 2 pi over b. B is the coefficient of x. So in this example, the coefficient of x is 3. So it becomes our b. And then the scale is the period divided by 4. So the period is 2 pi over 3. Then you divide it by 4 so that you get pi over 6. So that would be the scale. Then the first shift, you would get 3x plus pi and equate to 0. So for x, you get negative pi over 3. The phase shift is also called the horizontal shift. It's also called the horizontal shift. Then you would also have the vertical shift. The vertical shift in this case would be -4. That's how you name them. That's how you find them if you are asked to present them. Is that okay? So that
Yes, sir.
we so let's now do the actual graphs. Example 1.
So can you please bring back the other one? I didn't finish copying the previous
Alright.
part.
Or we can move on.
Yes,
So
sir.
just took a screenshot and then we move. Okay. Example 1. The instructions will be sketch throughout. So sketch one. Let's say 1 and example 1. So sketch f of x is equal to sketch f of x is equal to 1 plus 2 sine x plus pi over 2 for negative pi over 2 less or equal to x less or equal to 3 pi over 2. So normally when they ask you to sketch, you'll be given the interval. And that is the interval. So you sketch within the given interval. If not given, which is a very rare case, you sketch within the period. So our solution, when you want to sketch, we've got so many properties here. But for us to sketch, we have two methods. Method 1 is you just get the period. We say the period is 2 pi over b. That is the period. So you just get the period 2 pi over b, which is 2 pi over, what is b in this case? We said b is the coefficient of x. So when x is standing alone like this, it means the coefficient is 1. So our period is 2 pi. Then you get the scale. The scale is the period divided by 4. So we have 2 pi divided by 4, giving us pi over 2. Then you get the horizontal shift, which we call the phase shift. It's the same thing. In this case, it is x is equal to negative pi over 2, because you equate what is in the brackets to 0, and so for x.
Sir,
Hello.
from identities, we are going to graphs.
From graphs, we are going to equations and identity.
Oh.
So that when you have these three properties, you can attempt to sketch your graph. Catherine.
Sir, I'm still not clear on the P. On the scale.
On the
scale, that P. Where is it coming from?
That's a period.
Okay, thank you, sir.
Okay.
So, sir, the vertical shift there is 0, right?
Is 1. The number standing alone.
Oh.
So how do you find the
How the period?
Huh?
What's the question?
How do you find the P?
So you divide 360 by B of the question given. So the period has got a formula.
Sir, just a minute.
Hello?
There, the period. And can you? Yes, I'm asking as in, what's the difference between the scale and the period?
Between the scale and the period. The scale
Yes.
The scale comes from the period. The use of the scale is, when you're sketching, if you're given a graph paper, they would always give you a scale, is it? They'll tell you you're running from 0
Yes.
to 2 to 4, 6. And the period is, when does the sine graph complete its oscillation? So it completes the oscillation in its period. So once you get to the period, sine will start repeating the behavior of the curve. That's the use of the period.
Okay.
So now, when you are given such a question and you obtain the period and the scale and the horizontal shift, you begin to sketch.
But, sir, why aren't we finding the other things like the vertical shift and the amplitude?
The
Like
question
what?
just says sketch. So we can sketch using these three properties.
Oh, okay.
So you always start from there. We are given the interval, but we always start from the horizontal shift. So we always start from negative pi over 2 to sketch this thing. So from negative.
Excuse, sir. I've got a question.
Ask.
Yeah. So, is it healthy, if the question has been given in lads, then you convert it in degrees, then you work it in using the degrees?
But the degrees and the pi's are just the same thing. You're given a conversion.
Also, even if you convert, it's just fine, right?
Even if you don't convert, it's just fine.
All right.
Why converting? So you
just a minute.
yes.
There on the period, since I'm saying on the period we have 2 pi, and on the range it's 3 pi over 2. How do you go about it?
No, the period was just helping us in this case to get the scale. So we are done with the period. It has given us a scale. We can now go to the interval.
So sir, actually when you have the scale and when you get let's say when you are given the range, then you find the period to be maybe something else. You just deal with the range which they have given you. Don't consider the period which you have found.
Yeah, you don't consider the period. So far, we are saying we are done with the period. We are done with this one. We're remaining with the scale. It's our key thing now. It's our key tool that we are having in our hands for us to sketch this. So we need the period to find the scale. Then we use the scale to cover up the given interval, starting from the horizontal shift. So our horizontal shift is negative pi over 2. So we'll be adding the scale. The purpose of the scale is to give us a spacing on the x important values. You know, you can sketch this thing starting from 0, 1, 2, 3, 4, 5 on the x values. But how do you know which ones are important? You use the scale. So we start from negative pi over 2. We'll be adding the scale to each number that we get. So negative pi over 2 plus pi over 2 will move to 0. 0 plus pi over 2, no, pi over 2 is 90. So 0 plus 90 will move to 90, which is pi over 2. 90 plus 90, 180. 180 is pi. 90 plus 90 plus 180, 270. 270 is 3 pi over 2. The interval tells us we should stop here. So we'll end at that point. Catherine?
So those numbers you're adding, you're just getting them, you're just picking them, and then on the x values, how do you know that it's supposed to be in the x?
So these are the x values, is it?
How do
So,
you know?
so you not always start from the horizontal shift. Add the scale to each number you obtain. You obtain starting from horizontal shift.
So,
Hello?
I'm kindly asking if you can just like go through like quickly, please. I just want to like get what you're doing. I can't get I can't follow nice. I haven't followed.
Okay. So starting from the note here, how do you obtain? What is important when you're sketching is knowing the points that are critical in that sketch. Each sketch will have points. If I want to sketch a quadratic, you always pick a point. You pick 0, you see what you get in the function, and have your sketch like that. They are always what we call important points of the sketch. So in this case, what will be the important points of the sketch? Just like we find the x-intercepts, the y-intercept, the turning point for a polynomial, what do you do to a trig function, specifically sine? Now we are saying for sine, I don't need to specifically look for turning points or intercepts. What I need to do is that I won't name them. Instead, I'll look for the period of sine. How do I find the period of sine? I divide 360. Initially, the period of sine has a formula. 360 divided by b of any function given of the sine. What is the position of b? The position of b is the coefficient of x. Whatever x will be placed, I'll rearrange that equation until it looks like this. And the coefficient of x is what I'll call b, and I'll divide the 2 pi or the 360 by b. The number I'll get is what is named as period of the function. When I want to sketch, I'll go back to the period and divide it by 4 because the sine graph has got 4 critical important points apart from the starting point. The starting point will always be the horizontal shift or the phase shift obtained by equating the bx plus c to 0. And then you solve for x. So we have a question of this nature, 1 plus 2 sine x plus pi over 2. How do I sketch then? I get the period first. I divide 2 pi by b. Our b in this case is 1. So we divide 2 pi by 1 and get 2 pi. What is the 2 pi for? When you already have an interval given in the question, the 2 pi is to help us get the scale. So our scale is the period divided by 4. And now the period is 2 pi. You divide by 4, you get pi over 2. Then look for the starting point. The starting point is the horizontal shift. So get the horizontal shift. We equate the inside. In the brackets, we equate to 0. And obtain that x is equal to negative pi over 2. So we'll go at negative pi over 2 and make it our starting point. Where do we go? We follow the interval. The interval goes to the right. So because the interval goes to the right, we'll add, because the interval goes to the right, we'll add the scale to the horizontal shift, and the number we'll get, we'll add the scale again until we get to 3 pi over 2. The scale is the spacing on the x values. So now we had negative pi over 2. That's what we have as our scale, as our horizontal shift. So we add pi over 2 to get another number on the x values. This will give us 0. So we have obtained a 0. We are not guessing a number. We have obtained the n number. We are getting the numbers by solving. We have obtained 0. From 0, where do we go? We add 0 plus pi over 2, which is 90. We get pi over 2. We have another x coordinate. This pi over 2 obtained, we add the same scale, pi over 2. We obtain pi. We have another x coordinate. We add to this number the same scale. It is our spacing in between the x coordinates. So we'll get 3 pi over 2. We have another x coordinate. We have covered the whole interval given in the question on the x values. Now you can't sketch if you only have the x values. You also need the y coordinates to form full points. So now you go back to the equation, to the function, and look for the corresponding y coordinates to the x coordinates you have obtained using the scale. So our first one to be looked for is what happens at negative pi over 2. So I'm doing this on the whole function. So you have 1 plus 2 sine negative pi over 2 plus pi over 2. When you say f of, you go where there is x and substitute that number. So where there is x, we take negative pi over 2. And we have 0 here. So we are dealing with 1 plus 2 sine 0. But sine 0 is 0. So we just get 1 here. So we have 1. So we have a point, negative pi over 2 comma 1. We move to 0. What is f of 0? F of 0 is 1 plus 2 sine pi over 2. Since where there is x, we'll place a 0. 0 plus pi over 2 is pi over 2. Now, pi over 2 is 90. What is sine 90? Sine 90 is 1. So we are dealing with 1 plus 2 multiplied by 1, giving us 3. So we have 0, 3. Another point. Then we go to f of pi over 2. We get 1 plus 2 sine pi over 2 plus pi over 2 will give us pi. So that we get sine pi is 0, so we obtain 1. So we have pi over 2 comma 1. Then we go to pi now. What is f of pi? So f of pi is equal to 1 plus 2
Sir,
sine, hello?
I am sorry, but I'm kind of lost here on f of 0. How do... Oh, okay. Thank you, it's fine.
Okay. So f of pi, where there is x, we take pi, then we add the pi over 2. We're just substituting. So pi plus pi over 2 will give us 3 pi over 2. But this is 270. Sine 270, we have 1 plus 2. Sine 270 is negative 1. So we get 1 minus 2, which is equal to negative 1. So we have a point pi, comma, negative 1. So we have a point here. Then we look for f of 3 pi over 2, which is 1 plus 2 sine 3 pi over 2 plus pi over 2. 270 plus 90, it gives us 2 pi, which is 360. But sine 360 is 0. So we get 1 plus 2 multiplied by 0, which is just 1. So we have another point, 1. Then we connect these points using a curve. And that's how we sketch. When you have points, if it's a straight line, you just connect the points. Now this is a curve, so we connect the points using the curve. You come here, move to here, there, up to here. And this is the graph of f of x. If we want, we can label it. This is f of x is equal to 1 plus 2 sine x plus pi over 2. And that's how you sketch
I have a
this
question.
function. Hello?
I want to ask, there where there's 1, isn't since 1, according to 1, it is a vertical shift, but why didn't you indicate on the graph that that is where the vertical shift the
The question just says sketch. And when you're sketching, we don't indicate that this is the horizontal shift, this is the vertical shift. We just place the sketch there and it will be clear that there was a shift done here, like it is in this case.
so even the upper limit, the lower limit, you don't have to indicate, as in there's no need of indicating where the upper limit and lower limit are.
No need.
Okay, thank you.
Hello?
Sammy, I'm confused.
Why are you confused?
These numbers almost everywhere. So these numbers you've put, it's the numbers you got that side, like for your x, and then you came to put them in here.
The numbers we got for...
Is there a way of you saying all this in a simple way? In simple terms? I don't know.
So what you must understand first is how to use the angles. Moving from the angles, you notice that all the x coordinates for this graph here are the angles. So when I'm looking for f of pi, I'm looking for f of an angle. So where there is x, I would take the pi, and then I'll add to pi over 2, which is another angle, and I'll form 270. If I know what sine 270 is, there's no need of being confused. I'll just substitute what the value is. So sine 270 is -1. So where there is sine 270, I place -1. I remain with an equation having only 1 plus 2 multiplied by -1. The number I get forms a full point with pi. And that's how you sketch every function. So this is example 1. We'll clear out some more doubts in example 2.
So before we clear out, sir, just show me how you did on the f of 0.
Hello?
What you did on f of 0 when you're finding the y component.
What is f of 0?
Yes.
F of 0 is 1 plus 2 sine 0 plus 90. What is 0 plus 90?
90.
It is 90. What is sine 90?
1.
Sine 90 is 1. So we have 1 plus 2 multiplied by 1, which is just equal to 3.
Okay, thank you, sir.
Okay. And that's how you obtain all the points. Example 2. Example 2, f of x is equal to, so example 2 we are still sketching. So sketch f of x is equal to -2, okay, that means +2 minus 3 cosec 2x minus minus 90 on the interval on the interval 45 less or equal to x less or equal to less or equal to 225 degrees. So I want to sketch this function. Our solution.
So,
Hello.
when I asked the question about the why aren't we finding the vertical shift and the amplitude, you said that no, it's not necessary when you're sketching. So when is it necessary for you to
If you
find the
use
amplitude?
if you use
And the
when they ask for them.
Oh, they ask for. All right. Okay. Thank you.
Yes. Okay. So when you are asked to sketch cosec, the first thing you do to answer to have the graph of cosec is to write the function as a sine function. That's your first thing to do. You write this function using sine. So you write this function using sine and then sketch the sine graph. Meaning you'll be doing two questions in one. So we write it as sine. And what is the period of sine? We've agreed it's 360 over b. What is b in this case? It is 2. So the period is 180 degrees. Then get the scale. The scale, it is the period divided by 4. So we have 180 divided by 4, which is equal to 45 degrees. Then get the first shift. The first shift, you get 2x minus 90 equate to 0. And so for x, it will be 45 degrees. Then sketch starting from the horizontal shift, 45 degrees. So from 45, you add the scale. So what is 45 plus 45? It is 90. What is 90 plus 45? It is 135. 135 plus 45.
180.
We get 180. What is 180 plus 45? We get
225.
225.
And the interval says we end at 225. So we end there. And then get back to the function now. What is f of 45? That is 2 minus 3 sine 2 multiplied by 45 minus
Sir,
90. Hello?
how did you find the 360 there? How you're getting it?
The one for the period.
Yes.
So this one, that's a formula that we use to obtain the period. The 2 pi we mentioned in one. We said it's either 2 pi or 360. Depending
All
on
right, thank you.
which family you are. So this is going to be 2 minus 3. 2 by 45 is 9. 90 minus 90 is 0. So sine 0 is 0. So we just get 2 here. So we have 45, 2. We have a point there. Then we move to f of 90 using sine 2 minus 3 sine 2 by 90 minus 90. This is 2 minus 3 sine 180 minus 90 is going to give us 90. So we get 2 minus 3 by 1, which is negative 1. So we have negative 1 against 90. So we go to f of 135. We have 2 minus 3 sine 2 by 135 minus 90. This is 2 minus 3 sine 2 by
Sir, I
135.
have
Hello?
asked. Yes, sir. I have asked. Like, how did it change from cosec to sine?
So we're saying when sketching cosec, what is cosec? Cosec is 1 over sine.
Yes.
So when they ask us to sketch cosec, we go through sine.
Okay.
And then we'll realize the cosec when you're done with sine.
All right.
So what is 2 by 135? This is 270. 270 minus 90, we get 180. And 180 gives us 0 for sine. So we have 2 minus 0, which is 2. We go back to 2. And then we find f of 180. This is 2 minus 3 sine 180 by 2. That's 360 minus 90. This is 2 minus 3 sine 270 and sine 270 is -1. So we get 2 plus 3, which is equal to 5. So we have 5 against 180. And then what is f of 225? So we get 2 minus 3 sine 225 by 2. That will give us 450. 450 minus 90. What do we get? That is 400 minus 40. That's 360. Sine 360 is 0. So we get 2 minus 3 by 0, which is equal to 2. So we get a 2 here. And if you only have one pen, you sketch this using dots. So you'd sketch it in this form. You'd sketch this in this form. Okay. This is the graph of sine, but the question is centered on cosec. So what do I do next? I would bring everywhere where we obtain sine to be 0. Everywhere where we are obtaining sine to be 0. If you noticed here, we had 0 coming from sine. We had 0 coming from sine. We also had 0 coming from sine. So those were giving us 2. We were getting 2 each time we had sine giving us 0. We were getting 2. So we go on the 2's and put what we call the vertical asymptotes. We put these. We now want to sketch the cosec. We put this and go to our sine graph. Where it is facing up, you switch it, it faces down. Where it is facing down, you switch it, it faces up. And this is what we call f of x is equal to 1 minus 3 cosec open 2x minus 90. That is how we sketch cosec.
Yeah.
Hello.
Yeah, just a minute. Here on the x, where x is 135. How come you found the value for y to be 1, but how come have you plotted where there's 2?
What do you mean 1? We found 2 minus 0, which is equal
I
to
mean,
2.
where is it? Oh, it's 2.
F of,
Oh, okay, I've seen.
yes.
So just a
I'm
bit
sorry,
on the asymptotes.
I was logged out.
Okay.
So just a bit on the asymptote.
On how to find the cosec, I've understood on how to sketch the sine. Now, where you say that where the sine is 0, son.
Since we know that cosec is 1 over sine, you'd agree with me that when sine is 0, cosec will be undefined at that point. We agreed cosec is 1 over sine. And so cosec 0 is 1 over sine 0, and so it is undefined. This means that when I'm using sine in the question which came with cosec, I must be careful. At each point I find sine 0, I know that my actual question cosec will be undefined at this point. Now the whole result of f of 45 is 2. So I'll keep 2. So everywhere I'll find 2, I know sine there should have been 0. Sine here should have given us 0. So we go to the 2. 2 is for y. So whenever we had something comma 2, we put vertical asymptotes, meaning that the function is undefined on these points, we never get anything using cosec on those points because it is something over 0, which is undefined. To mean undefined, you draw the vertical asymptotes. The graph of cosec will never touch these points. Is that a question? The one who was unmuted?
Sir,
Mhm.
so like if we're not given the range to say if we're not given the what is that, the domain, the one from 45 to 225, we would have just reached up to 180, right? Since that's the period.
Now, when you would have tried to, when there's no interval, you can sketch to anywhere you feel like ending.
Okay, thank you, sir.
So, sir, how are you getting the asymptotes? Like, how do you determine the asymptotes? Like, is this why the graph should pass C or not? How do you determine?
The asymptote is where the function is undefined. That is what we call an asymptote, where the function is undefined. Our function cosec will be undefined when sine is 0. Since cosec is 1 over sine, the emphasis is that we don't know what 1 over 0 is. That's why we are putting the vertical asymptote, saying we don't know at what value, if this must touch the graph, at what value it touches the graph. We don't know.
Sir, but what don't you know?
What is 1 over 0?
It's undefined.
So I don't know. Who knows?
Oh, sir. Sir, I just didn't get your sentence. That's it. Like, I didn't get you. Please, can you repeat yourself?
Only God knows.
Please repeat your sentence to
So we are
say
saying
the.
that wherever sine is 0, cosec will be undefined. And to show that cosec is undefined here, we are putting the dotted vertical asymptote lines. And then flip now the graph of sine. Where it is going up, we take it down. Where it is going down, we take it up. And that's how we get that graph.
So the curves will be in a way that they don't touch the tuma dots.
They never touch the tuma dots.
Okay, thank you, sir.
So 2 in 1. We've answered sine, and then we extended it to cosec because that was our question. So the good part of this method of sketching is that you don't get to be bothered about the vertical asymptote, the amplitude. The method takes care of everything. So even if you don't know how to use the vertical asymptote, you still get this correct. Even if you don't know what it means to have an amplitude, you still get this thing correct. That's the beauty of this method. So this was based on sine and cosec. We move to cos and sec as our example 3.
Sir,
Hello.
so you mean that if we had sec, we could have first sketched the graph of cos and you find where cos is giving us 0, is it? What you're meaning compare with this one.
Exactly.
Okay, thank you.
So let's go there now. Example 3. Sketch f of x is equal to 2 plus well, let me sketch something that is f of x is -1 plus 2 cos 3x minus pi. Okay, so we'll come back to the interval. I'll put the interval after to get the properties. So what's the period here? For the graph of cos and sine, they share the same properties. So it is still 2 pi over b, and b is at the same point just like it was in sine. So we'll get 2 pi over 3. So that our scale becomes the period over 4, which is 2 pi over 3 over 4. And this is pi over 6. Then the horizontal shift.
Excuse me, sir.
Hello?
Where is 3 coming from? There on B, the period.
So 3 is our B. Remember the position of B. B is the coefficient of x. These properties hold also for cos. Where do I put it? I'll put it here. These properties hold for cos. So where is the B coming from? It is the coefficient of x, is it? Let's go and look for it. Here we have 3 as the coefficient of x, so we have called it B. And that is its genesis.
All right, thank you very much, sir.
Okay. Then horizontal shift. I have a question from Sarah. Okay. Horizontal shift, you equate 3x minus pi to 0, and so for x, so you get pi over 3. So I want to put an interval. So how do I put the interval? Let me see. to pi over 3. Okay. So starting from sketch from pi over 3 less or equal to x less or equal to pi. So once we have a horizontal shift, we can start sketching. So we'll start from pi over 3. Then we add the scale. So what is pi over 3? So we know pi over 3 is 60. So adding, we can use the degrees. What is 60 plus 30? We obtain 90. 90 is pi over 2. What is 90 plus 30? We get 120. Convert it to degrees, to radians. So we have got 2 over 3. We get 2 pi over 3. And then we knew this was 120. 120 plus 30, we get 150. Convert it to radian. So we have 3 here, 5, 6. So we got 5 pi over 6. And then 150 plus 30, we get 180. 180 is just pi. So we have got the interval, every point in radian.
Sir,
Hello.
so you mean the pi over 3 is a 30?
It's a 60.
A 60.
A pi over 6 is a 30. That is our
Oh,
scale.
okay.
So if you notice, we are adding the scale to every number we obtain as we move, starting from the first number, the horizontal shift. So you move from pi over 3, we now start obtaining the corresponding values. So what is f of pi
Excuse
over
me, sir.
3? Hello?
Where is the pi over 2 coming from?
The pi over 2 is 60 plus 30, which is 90. 90 is pi over 2.
Or
Is the question?
in short, sir, kindly explain where you've obtained those numbers you've written there.
So the emphasis is that for you to sketch this graph, you need to have the x and y coordinates, only the important ones. And to get the x coordinates, you start from the horizontal shift and then keep adding the scale. Now our horizontal shift is pi over 3. Pi over 3 is the same as 60. We have converted pi over 3 to 60 for easy addition, but our answers must be taken back to radians. So we'll start from pi over 3, we add pi over 6. Pi over 6 is 30 when you convert it. So now we have pi over 3, which is 60, plus 30 to obtain the second point after having the initial horizontal shift. So we add, we get 90. 90, we add 30, we get 120. We add 30, we get 150. We add 30, we get 180. We end there because that's where the interval is ending. We now want to use those
Thank you, sir.
to get the y coordinate. So you say, okay, I'll start from the pi over 3. What is f of pi over 3? It is -1 plus 2 cos 3 by pi over 3 minus pi. This is the same as -1 plus 2 cos 0. But cos 0 is 1. So we have -1 plus 2, which is 1. Hello?
I'm sorry, why haven't you redefined this graph in terms of sine?
This is cos.
So the other one was a cosine
Cosec.
or cosec, okay.
So it's only cosec which is defined in sine form.
Okay, okay. All right, thank you.
Okay. So we have pi over 3 comma 1. Next, what is f of pi over 2? If you want, when calculating this, you can even be using the degrees. And then just take your answers there. So, since we have found them in degrees, I can even say what is f of 90. So we have -1 plus 2 cos 3 by 90 minus 180, the pi. This is -1 plus 2 cos 90 by 3, that's 270. 270 minus 180, you get 90. Cos 90 is 0, so here we get -1. So we have -1.
Sir,
Yeah. Hello.
I have a question.
Uh-huh.
There was a certain tutorial sheet that was released. What was happening was that when you are finding the answers, the values for like they were bigger than the domain. Like you find things like 450, you find things like just there where you're saying 270 minus 90. Maybe you find 500, like big numbers out of the domain. What are you supposed to do then? Yeah.
What did we say we should be doing? We use the coterminal angles.
Oh, until it reduces to the same domain that you have been given, right?
Until it reduces to what you are able to know.
All right. Okay, thank you.
So we have, so here, okay, so we go to the
So I have a
next
question.
one.
Yeah, on finding the y values there, like when we substitute 60 on x, is it not going to give us -1?
We did substitute 60 and we got pi minus pi, which was 0 inside as an angle.
Yes.
And what is cos 0?
Cos 0 is 1.
So what is 2 times 1? We get 2. 2 minus 1 is 1.
Okay, all right, thank you, I see.
So 2 pi over 3, we found it to be 120. So what is f of 120? Get -1 plus 2 cosine 3 by 120 minus 180. That is -1 plus 2 cosine 360 minus 180. We get 180. And what is cos 180? Is negative 1. So we get negative 1 minus 2, which is negative 3. So we have negative 3 against 2 pi. Over 3. Then we go to f of 150. That is negative 1 plus 2 cosine 3 by 150. That's 450 minus 180. Giving us negative 1 plus 2 cosine 270. But 270, cos 270, so we have negative 1 plus 2. Cos 270 is 0. So we obtain negative 1. So we have negative 1 here. And then f of 180, that is negative 1 plus 2 cos 180 by 3. What is 180 by 3? 3 by 180 minus 180. I know it is negative 1 plus 2 cos 360. But cos 360 is 1. So we get positive 1. So we have positive 1. And then we can draw our sketch. So it's coming. So it's supposed to pass through the point here. So if I miss it, I just pull my point. Is that okay? Any questions? Example 4.
Sir, kindly bring back the previous slide. Thank you, sir.
Now, sir, here are we not using the vertical sheet?
It has been used.
Oh, where?
Where was the graph supposed to be? If there's no vertical shift, you would obtain.
It would have been at 0, but
Yes.
because of the -1, the vertical shift.
So the pivot points moving to -1.
Okay. All right, guys.
Sir, I have a question on the same vertical shift. The vertical shift is -1. So why is it on the positive side? Why didn't it go on the negative side?
What is on the positive side?
The shift is like, if initially it could have been on 0, it could have stayed on 0 here. This graph, if there was no vertical shift. But because of the vertical shift, which is -1, it has now started. Yes, it has.
Initially, it should have started at 2.
At 2.
Now it has stayed at 1.
Okay, so the vertical shift is in the y-axis. Okay, thank you.
Yes. So again, when sketching cosec, you work with cos. So obtain every property using cos. So the period is 360 over 2, giving us 180. The scale is 180 over 4, giving us 45. The phase shift is 45. So we sketch. Our sketch will start from 45. 45 plus 45, you get 90, plus 45, 135, plus 45, 180, plus 45, 225. We now look for the y's. So what is f of 45? We are taking it to where there is cos. So we'll have cos 0. Cos 0 is 1, so we get -1 here. So we have -1, 45, -1. What is f of 90? You get 2 minus 3 cos 90. Cos 90 is 0, so we get 2. So we have 90, 2. What is f of 135? Is 2 minus 3 cos 180. Cos 180 is -1, so we have 2 minus 3 by -1, and this is 5. So we go to 5. Then f of 180 will give us 2 minus 3 cosine 270, giving us 2 minus 3 by 0. This is 2. And f of 225, it will be -1, even if I don't calculate. So what you notice is that if you solve so many questions, you get to know the pattern. But once I start going up and I find one that is coming down, I'll keep coming down all the way up the last number. And then we are sketching cosec, so we can dot this one. When we are sketching sec, so we can dot this one. And then wherever cos was 0 at 90, so anywhere else where there is 2, we'll have the asymptotes, the vertical asymptotes. We'll have the vertical asymptotes. And pull things up. So this one must be taken up. This one must be brought down. This one must be brought down. And this is what you call the sketch of sec. So here the understanding is that if there was another point this side, this graph would have gone up, so would have brought it down. That's why we just gave the half piece.
So what if we were told to find, let's say, the domain and the range? How can you go about it?
You would just for the domain you'd remove the asymptotes. So we are dealing with 90 to 180. And then you'll be skipping. So you only give the special domain. So you would have unions here. Or you can just give the domain within the given interval. You'll say, okay, if you're asking for the domain in the given interval, the domain is 45 to 90, union 90 to 180, union 180 to 225. Then the range is from 5 included. I'll start from the smallest interval, from negative infinity all the way up to negative 1 included, union 5 included to positive infinity.
Now,
Hello.
why is it that the vertical asymptotes on this one are passing on 90 and 180? Like the interval is 90, and the other ones it was on 45, and then like that. What are you supposed to follow? What's the rule?
So when calculating, whenever this guy here comes out to be 0, you know there will be an asymptote there, because sec is 1 over cos. So that's the rule.
Sir, I didn't understand on the domain. Why is it that the 45 is not included when the 9 as well is not included, but as it is
Oh,
saying
for the
here that
domain,
the
the 45 should be included. There's no asymptote there. The 90, there's an asymptote. So even the 225 we include, the 180 don't include because there's an asymptote there.
So at which guy should be 0?
Hello?
You said that which guy should be 0?
Okay. So we said sec is 1 over cos. And we are emphasizing that 1 over 0 is undefined. And that is where the asymptotes are coming in. So if I'm solving and I say cos 90 is 0, that means that the sec won't be defined there. So by the time I go back to sec, I'll put an asymptote there because I know if I insist on sec 90, it will be 1 over cos 90, which is undefined. So I'll have 2 minus 3 multiplied by undefined thing. That's why we have an asymptote.
So kindly go back to the previous page because that one for sine you didn't say the 0 was not at the 0 was not at sine 0. It was at the first because there was a phase shift. So you are starting where the graph is starting. I think that's where I started counting from. Now this one just went straight to 90.
So same thing.
Yes, this graph, it's giving us 0 at 45, but sine 45 is not 0. So I think you said this one you start counting from 45, but when you look at the cosine, you just went straight to 90. I don't understand. I don't get it there.
When we said sine 0 is 0. But cos 0 is not 0. Cos 0 is negative 1. I mean, cos 0 is 1, so I have no issue with this piece here. The issue will be cos 90, which is 0. But for sine 90 is 1, so I have no issue with 90. I don't know if you get that.
So the other one we don't have 0. It's starting at 45. The sine function, the one we drew that side.
Just like this guy is starting at 45, is it?
Yes.
Now, when we use 45 in this function, we'll get 45 by 2, that is 90. 90 minus 90 is 0. So we'll have cos 0. Cos 0 is defined, it is 1. So when cos 0 is 1, sec 0 will be defined as well. So we have no issue with 45. When it was sine, we had an issue because when we used 45 in sine, we got sine 0. Sine 0 is 0. So cosec 0 will be undefined, meaning cosec 45 will be undefined.
So I get it now. Thank you.
So
My
I
network
have a
was
question.
repeat what you just like explain what you explained. Like
What's your question?
explain what you explained so that for him to get it, I think I might also get it.
You ask your question.
I also don't get like why sine 45. Why the sine graph has an asymptote in 45.
The sine graph has an asymptote on 45 because the 45 for sine, this one here, is giving us a zero angle inside. And sine 0 is 0. So cosec 0 will be undefined.
Okay, I get now, sir. Thank you.
So I have a question on the range. How is it that the for it the negative 1 and the 5 are included in there?
Because we are obtaining those numbers. The range is what you are able to obtain.
Oh, okay. All right. Thank you.
The range is what you are able to obtain.
Okay. All right. All right. Thank you. Even if it's so, it's at the point where the even if it's at the point where the like you left out the one for the asymptote, right? Because it's on the asymptote, right?
That's the domain.
No, sir. Like check here. 2 is also there. Like
Yeah.
we've also found 2, but we didn't put it there. We just said 5 going upwards because 2 is part of the
The range is for the sec and not for cos.
Oh, all right. Okay, thank you.
Sir,
Hello.
I just wanted to ask, are we having physics?
No, today we only have math.
Okay, thank you.
Sir,
Mhm.
sir,
Hello.
may you send the record on the group,
We are not yet done.
sir?
We are not yet done.
I join name.
Oh, I'll send.
Okay. Okay.
So,
Uh-huh.
my understanding, the way you have explained is we are equating the angle which is 2x minus 90. If we replace anything there and it gives us 90 for the cos, then it's an asymptote. And if for sine, if it gives us 0, then it's an asymptote. You forget everything else. The 2 minus 3 cos negative.
Yeah, we are centering our asymptote discussion on the angle inside sec.
All right, so thank you.
Mm-hmm. Another one. Example 5. Sketch f of x is equal to tan x. For tan, the period for tan, so let's talk about the general equation of tan. If f of x is a tan bx plus c plus d, the period here is pi over b, which is 180 over b. This is for tan and cot. It's no longer 2 pi, it's no longer 360, it's just 180. Because tan will complete its oscillation within 180. And so the scale will be the period over 2. The horizontal shift, vertical shift, and amplitude are still the same. So back to our example. The period will be.
So what have you said that the vertical shift, the what is what?
It's the same as sine, cos, cosec, and sec.
So the reason why we were dividing by 4 when it came to sine and cos, it's because them they have two what? 2 cycles.
They complete their cycle within 360.
Or they complete their cycle within 360.
So they have 2 turning points within the full period.
Okay.
So what's the period here for tan? Pi over 1. And so the scale is going to be pi over 2. Horizontal shift is 0. The phase shift is 0. So when sketching tan, so I want to sketch this one. Let's sketch it from negative pi from negative 2 pi to 2 pi. That's the interval. So using our scale, starting from 0, we'll go to pi over 2. We'll go to pi, 3 pi over 2, and then to 2 pi. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And then we have, so if you look at this, we can just do the other side, it will be the same as the other side. So what is f of 0? Tan 0 is 0. So we have a point here. F of 90, tan 90 is undefined. So because tan 90 is undefined, we put an asymptote on pi over 2. And then f of 180, tan 180 is 0. So we put a point, meaning that, again, 270 is undefined. Then another 0. So 0 here, undefined here. 0 here, undefined here. And 0 there. Now for tan, have you seen that it has got so many undefined lines? So tan takes this orientation. And that's how you graph tan.
Now, how is the phase shift equal to 0?
You equate bx plus c to 0.
Okay, sir.
That's how easy the graph of tan is. The graph of cot is not like the way we're explaining sec and cosec. It's different. And this orientation is for positive tan. If you find tan is negative, the lines will be coming in the lines will be coming in this direction. If it was to be negative. So take note. Warrior.
Sir, kindly go through for me. I got locked out.
Okay. So for tan, the period has changed. It's now pi over b, 180 over b, because tan completes its oscillation within 180. And so the scale also will just be looking for 2 points. So just be dividing it by 2. So pi divided by 2 over scale. Now if you look at this function tan x, the first shift here is 0. So we place our scale from negative 2 pi to 2 pi. When you solve for tan 0, you get that tan 0 is 0. But tan 90 is undefined. So every after 90, you'll be getting undefined things. I mean, every after 180. Meaning from 0 to 90, it's there. At 90, it's undefined. From 90 to 180, it's there. 180 to 270 is there. At 270, it's undefined because tan 270 is also undefined. And that's how the sketch comes out in that orientation. So we'll do more examples on the graphing. This was day one of it. So you have so many questions as you go through on your own. And then we'll do one question from each part. But for tan, we'll do 2 because we haven't done for cot. And I feel people are tired. That's why Catherine is quite.
No, not my sister.
So saving this as trig graphs. Okay, then I save it. Have a good day.
Thank you, sir.